Yes, Professor.
Okay, so let us start review problems on rigid body equilibrium. In the first problem, the C bracket is supported at A, B, and C by rollers. Determine the reactions at the supports. So here, from the figure, what is the types of supports we have? When you see this symbol, this is what? This is a roller, okay? When you see a circle, this is a roller. The roller develop a reaction always perpendicular to contact. So here, at point A, where is contact? This is the contact line. So how will be the reaction of the roller? It will be perpendicular to this contact, okay? At B, you have like here a circular track. So the perpendicular to contact is tangent to the circle, so it's perpendicular to the radius. And here also, it is tangent to the circle, so perpendicular to radius. So I can say that the force here is like this, downward. Always the roller force is towards the structure, okay? So here it is up, and here it is up also, okay? So I have three reactions to calculate, and since I am in 2D equilibrium, then I can write three equations, okay? Now, what is the equations I can write? First, I should try to find the easiest equation. The first equation that can be done is sum of moments about which point. Which point will give me the easiest moment equation? This one. Why? Who can tell me? Why sum of moment about this point will be the easiest one to do?
B and C are passing through it.
Exactly. Because the two reaction forces, RB and RC, are passing towards O. So they cannot produce a moment about O. So in this case, I will cancel out the moment of these two. Okay? So here they call them NB. This is NB. And this is NC. By doing sum of moment about O, I will only have moment of the other forces, which are NA and F. Okay? So if I choose counterclockwise direction as positive, then I have the moment of NA about O. If I extend the line of NA and I do the perpendicular from O, this is the perpendicular line. The distance is equal to A. So the moment of NA about O is plus NA times A, while for F, first it's doing a clockwise moment. So it's minus F times, if I take the distance, this distance is equal to the radius here of this circle, which is B. Okay, so it's minus F times B equals to 0. This is equation number 1. I got it from doing sum of moments about O. Now, the second equation I can write is, now since I have one relation, the other two relations, or I can choose another point to do sum of moments about, okay? But here it's a little bit complex, so the easiest equations to use is sum of x and sum of y equal to 0. So if I apply now sum of x equal to 0, so now I will do sum of x equal to 0. What are the forces having x component? NA is only along y, no component along x. F also only along y. So I have the components of NB and NC. I should project NB and NC along y, along x, sorry. So this is the projection of NB along x. This is the projection of NC along x. You can see that NB has a positive projection along x, while NC has a negative projection along x. And to project, I should just know the angle. And if you look at your figure, you know that NB is doing with y in x an angle of theta 1. Okay, so if I want to project on x, I do sine theta 1. While NC is doing with y an angle theta 2. So if I project on x, I should do sine theta 2. So I get the sum of x relation will give me plus NB sine theta 1 minus NC sine theta 2 equals to 0. This is relation number 2. And finally, I will do the third relation is sum of forces along y. Sum of forces along y equals to 0.
Excuse me, doctor.
Yes,
This أول سطر تحت solution. What's that relation?
it is sum of moment about O. Okay, sum of
Yes.
moment about O equals to 0. Okay, and we selected O because NB and NC are passing by O. Okay.
Yes, thank you.
Now the third relation, sum of y equals to 0. What are the forces along y? You have minus NA, minus F, and plus the component of NB and NC about y on y. So you see that NB has a positive projection and also NC has a positive projection along y. And since these forces are doing angles with y, theta 1 and theta 2, so to project, I do cosine. So it's plus NB cosine theta 1 plus NC cosine theta 2 minus NA minus F equals to 0. So I end up here with a system of 3 equations with 3 unknowns. I can find my unknowns. Okay? Please be familiar with calculator calculation. Sometimes you solve it on your hand, it will take you time. Just once you put the 3 relations, okay, you can use your calculator to find the 3 unknowns. Any question on this problem? Okay. Another problem, the car is being towed at constant velocity up the incline using the cable at C. The car has a mass of m and center at G. The tires are free to roll. Determine the reactions on both wheels at A and B and the tension in the cable at C. Okay. When they say the tires are free to roll, so I don't have friction forces. Okay. So here, what are the forces acting on my car? I have the normal reaction of the ground at A and at B. Since they said the wheels are free to roll, I don't have friction. So first I have an A and an B. Of course, I have the weight of the car. The weight is applied at the center of mass, G. So the weight is always vertical, applied at G. So this is W. And I have the force F, which is doing an angle theta 2 with the inclined line. So these are my forces. Okay. Now, the number of unknowns I have 3 unknowns here. I have the reaction NA, the reaction NB, and the tension in the cable. I have 3 unknowns and I can write 3 equilibrium relations. Why here I can write the equilibrium relation? Here it's a dynamic equilibrium, not static equilibrium. Because it's true that the car is moving, but they said at constant velocity. Okay? Constant velocity means what? Means A equal to 0. And from Newton's second law, sum of forces equal ma. So if A is 0, I go back to the static relation. So if you remember when we introduced the static chapter, we said that we have dynamic equilibrium and static equilibrium. Static equilibrium means that I am at rest. Dynamic equilibrium means that I am moving but with a constant velocity on a straight line. This means that no acceleration. So I go back to the same relation, which is sum of forces equal to 0. Okay? Now, what are the equations I can write? First, of course, I should select an XY coordinate system. Here, if you want, since they gave me the angle of F with the horizontal, and I know that NA and NB, sorry, with the incline, and I know that NA and NB are perpendicular to the incline. So here it is easier to take XY like this. I can take X along the inclined line and Y perpendicular to the inclined line, because this will facilitate my projection. Okay, so this is X, this is Y. I will start by writing sum of Y equal to 0. So this first relation here represents sum of Y equals to 0. What do I have along Y in this problem? First, Y is the perpendicular to the inclined line. So I have plus NA plus NB. For NA and NB, no need to project because they are already along Y. For the first F, I know that it's doing an angle theta 2 with the inclined line. So if I want to project on the inclined line, I do cosine theta 2. While if I want to project on the perpendicular to the inclined line, I will do sine theta 2. And it is a positive projection on Y. So it's plus F sine theta 2. I still only have the weight. Okay, so let me clear everything so to do the weight. For the weight, what I know is the weight is vertical. Okay, the weight is along the vertical line. And since the incline is doing with the horizontal here, they gave me the angle. Okay, so as you can see here, the angle between the inclined line and the horizontal is given to be theta 1. Since the weight is vertical, perpendicular to the horizontal, then the weight angle with the inclined line will be 90 minus theta 1. So if I want to project the weight on the inclined line, I will do cosine 90 minus theta 1. And if I want to project the weight on the perpendicular, I do sine 90 minus theta 1, which is cosine theta 1. Okay, so also you can see it in another way. This is the weight, and this is Y direction in my problem. Okay, why is this angle here is theta 1? Because the weight is perpendicular to the horizontal, and the Y-axis is perpendicular to the inclined line. And since the angle between the horizontal and the inclined is theta 1, when you construct the perpendicular to the first and the perpendicular to the second, the angle formed will be equal to theta 1. So you can say that the angle between the weight and Y is theta 1. So when you project on Y, you should do cosine theta 1. And since it's a negative projection, so it's minus mg cosine theta 1. Okay? In this way, I get my first relation, which represents sum of Y equal to 0. Now, my second relation, I can get it by projecting along X. Okay? So if I project my forces along X, what do I have? As we said, NA and NB is already perpendicular to the inclined line, so no component along X. I will just have the component of F, which is F cosine theta 2, and the component of Y, which is minus mg sine theta 1. So or you do sine theta 1, or you do cosine 90 minus theta 1, which is the same. Okay, so here I got the first two relations, which are sum of forces. This is sum of forces along Y equals to 0, and this is sum of forces along X equal to 0. I still need one relation. The first relation needed requires to do sum of moment about a certain point. You can select any point you want in your figure. Okay, and here, for example, if we select point A, let's say, okay, if you want to do sum of moments about A, what will be your result? So also let me clear it now. Oh, I already know it's okay. So now if I do sum of moments about A equals to 0, what are the moment of forces? First, for the force F, okay, for F, I can decompose it into two parts, X component and Y component, okay? Now, I will select a positive direction. Let us say the counterclockwise is positive. This is my positive direction. So for Fx component, what is Fx component? It's F cosine theta 2. For the X component, I should multiply by which length to get the moment about A? Look, remember always the technique. I extend the line of the force and I do the perpendicular.
Half E.
No, the perpendicular is A. Look here, because E is the distance to G, okay? While F is applied at C. So you should take this distance here, okay? This distance is equal to A. This one here, small one here, okay? So I should multiply F cosine theta 2 by A. And since it's rotating counterclockwise, so it's a positive moment. So I start by plus F cosine theta 2 times A. Now, the Y component of F is doing a clockwise moment about A, so it's negative. And I should multiply by which distance? The perpendicular from A to the line of action of the force, which is D. So here, it's wrong بالsolution طبعا. Let me fix it. Please correct it, okay? It's not B, it's D. So it's minus F sine theta times D. Now, for the weight, okay, for the weight, I will do the same. I will decompose the weight into two components. I have the component along Y and the component along X. To start with the component along Y, the component along Y is doing a clockwise moment about A. So the moment is negative. So it's minus, the Y component was F cosine, mg cosine theta 1, okay? And I multiply by which distance? The Y component. If I'm doing sum of moments about A, for the Y component, I should multiply by which distance? C, okay? Look, this is Y component, okay? If you project from A, the perpendicular from A to Y component will give you distance C, okay? So it's minus, because it's a clockwise moment, it's minus mg cosine theta 1 times C. So this part is the moment of the Y component of the weight. Now, for the X component of the weight, first, also it's a clockwise moment about A, so it's negative. But I should multiply now by which distance? So if I extend the line of action of this force, and I draw the perpendicular, let me clear it now for it to be clear, okay? This is the X component of the weight. The distance from A to this line, if you extend it like this and you draw the perpendicular from A, this is the distance you should consider. This distance is equal to this one, equal to E, okay? So you should multiply, you should do minus mg sine theta 1 times E. So this represents the component of moment of X, component of weight about A, okay? And the last force is NB, because NA, no moment, since it's passing by A. I still only have the moment of NB. For the moment of NB, it's a counterclockwise moment, because it's rotating in the counterclockwise direction. And I should multiply by which distance? The perpendicular from A to the force, which is C plus B. So also here they are confusing D and with other term, okay? D and B يقلبون in this problem. So here it's not plus D, it's C plus B. كمان please pay attention. I will correct it here. يعني هون هن they switched B and D. Okay, we already corrected here. B is D here. So here it should be D. Okay, and here it should be instead of DB. Because this is the distance. It's C plus B. Okay, so now I got 3 equations and I have 3 unknowns. Using my calculator, I can solve the system. You know how to use the calculator for solving of a system of 3 equations with 3 unknowns?
Yes, Professor.
Okay, if someone don't know, let me know to help. Okay. Any question on these problems? Okay, so next time we will continue to do problems on chapter of rigid body equilibrium. Okay, any question before we stop? So see you on Friday. Bye.